So in statistics, there's two kinds of groups that you use for computations. You either use a sample or a population. Let me explain that in a little more detail. So a population is every one of a specific trait, or criteria. So it could be every person on Earth, or it could be every person on Earth who's in high school. See, it just depends. It can be anything you want. Every sheet of paper ever manufactured, every tree. It can be whatever. A sample is a subsection that matches up to a population. So it could be 100 papers of lightness level 97 or 100 randomly selected papers of any random lightness level. It could be 100 redwood trees, really whatever, right? It just has to represent a certain population. So, when we collect quantitative data about these, we obviously have to calculate means, and this is the first way they differ. When we're talking about means, with a sample, we use what's called X bar to represent the mean. Well, with a population, we use what's called mu. It's a Greek letter. These are not computed differently. However, when it comes to standard deviation, they are. In a sample, we use an S, and the formula is given down here, with degrees of freedom, which I'll explain in a moment. Well, with a population, we use sigma, and we divide by the total number. The degrees of freedom is n-1. This idea comes from the idea that the standard deviation is usually slightly shrunk by the lack of outliers because the sample is slightly smaller than the total population, right? And as it gets larger and larger, the effect of n-1 compared to n gets smaller, so it works. Now, when we're calculating z-scores, naturally this changes the formula. So if we're using a sample, we use X bar and S, and if we're using population, we use mu and sigma. And here's a handy little graph of a probability density function to help explain that. Alright, well, thanks for watching. Hope that clarified some stuff for you AP Stats students.